Today we are going to talk about two fundamental data types called float and double. Our outline of this lecture would be to study float, double, long double, their sizes and the difference between them. We are also going to have a brief introduction to fixed and floating point. We will also see some coding examples to help illustrate the concept of float, double and long double. Let's understand what float, double, long double is used for. Like int data type is used to represent integer, char data type is used to represent characters. Similarly, float, double and long double are used in representing fractional or real numbers. For example, 3.14, 0.678, minus 3276.789, 0.0000009999, etc. etc. These different data types are of different sizes as well. In my system, float takes 4 bytes of space, double takes 8 bytes of memory space, and long double takes 12 bytes of memory space. Size of these data types totally depend on the system that we are working on. For example, it is possible that size of these data types are same in your PC, or maybe any two of them are same, or maybe all of them are different as in my computer. There are several ways to represent fractional numbers, or you can say real numbers on computer. And one of the most common representation in modern computers is IEEE 754 floating point representation. Float data type follows IEEE 754 single precision floating point number representation. Double follows IEEE 754 double precision floating point representation. And long double follows extended precision floating point. We have two different representations for fractional numbers. One is fixed point representation and the other one is floating point representation. Let's see what do we mean by fixed and floating points. Why floating point is used in modern computers and fixed point isn't. What is the difference between fixed and floating point? Fixed point representation is a natural representation of which we the human beings are familiar with. We follow the same principle when we write fractional numbers like for example minus 3.33 by fixing the decimal point between 3 and 33. Let's say, suppose we are available with 4 places to enter the fractional numbers. Suppose first place is fixed for sign, second place is fixed for integer, and the last 2 places are fixed for fraction part. The minimum value possible with such a representation would be minus 9.99, and the maximum value that would be possible is plus 9.99, isn't it? You can represent any real number between minus 9.99 to plus 9.99, but up to 2 decimal places after the decimal point. This means you won't be able to represent numbers like minus 7.9765 or 0.00067 or 99.99999 and so on. You can, but you have to truncate some digits at the end. Means, if you want to represent minus 7.9765, then you would only be able to represent minus 7.97. 65 is truncated and removed. This is called reducing the precision. Floating point representation, on the other hand, is quite unnatural way of representing real numbers. It requires formula to represent real numbers. For example, suppose again we have only 4 places to enter the digits. First place is fixed for sign, next 2 places are fixed for exponent, and the last place is fixed for mantissa, or you can say significant. Now the formula to represent real numbers would be 0.m into base to the power of exponent. Here base is 10 because in our example we are representing the decimal numbers, therefore the base needs to be 10. Exponent is plus 9. The first place of the exponent is fixed for sign and the next place for the integer. M represents the mantissa part. Here in our example this is 9. If you want to represent the minimum value, then this is minus 0.9 into 10 to the power plus 9. Here 9 is our mantissa, plus 9 represents the exponent, and this negative sign is this sign over here. And the maximum value would be plus 0.9 into 10 to the power of plus 9. As you can see here, there is a huge difference between fixed point and floating point. Fixed point would be able to represent very least range of fractional values. While on the other hand, floating point representation using equal number of places would be able to represent much larger range of values. Isn't that so? Here you can shift the decimal point and thus allowing more numbers to be represented easily. That is why it is called floating point, because the decimal point is not fixed. For example, instead of 0.9, if you want to represent 9.0, you would be able to do that by reducing the exponent to 1 and make it plus 8. Minus 0.9 into 10 raised to the power plus 9 is very small value as compared to minus 9.99. And plus 0.9 into 10 raised to the power plus 9 is very large value as compared to plus 9.99. This is the reason why floating point is preferred over fixed point. This is the brief introduction to fixed and floating points. This topic is the part of computer organization and architecture, and explaining any further details regarding this topic is out of the scope of this lecture. Let's see why 3 different data types we have. Is it not sufficient to have only one data type like integer and character? What is the need of having 3 different data types? Let's not talk much about this and let the code speaks it out. Before explaining the code what I have written over here, it is better to execute the code first. Let's build and run. As size of float is 4 bytes in my computer, therefore in the first line 4 is printed. Size of double is 8 bytes, therefore 8 is printed. Size of long double is 12 bytes, therefore 12 is printed onto the screen. In the first line, I have declared a variable of float type and assigned it a value which is famously known as pi. Value of pi is 3.14159265358979932 and so on. It is going on continuously without even repetition of the digits. That is why it is called irrational number. To the second variable, I assigned the same value. To the third variable, I also assigned the same value but extended it by adding random digits at the end. We can print the contents of the float variable by using %f over here. Here 0.16 means that after the decimal point, I need to print digits 16 places long. Like if I want to print only 2 integers after the decimal point, then I will put 2 instead of 16. And let's see the output. Here you can see after decimal point only 2 values are getting printed. That is what it means. If I change this to 16 again, then this is what it prints. Up to 16 decimal values it will print. Similarly, we can print the contents of double variable using %f again. The actual format specifier for double is %lf. This is small l and this is small f. But some compiler won't accept it. Therefore, %f will also work. And to print long double, we need to put format specifier capital L, small f. Putting capital L is important because small l is for double and capital L is for long double. Now let's understand the major difference between float double and long double by seeing the output. If you observe it carefully, before this 2, everything is as it is what we have assigned into this variable. That is 3.141592. Here also this is 3.141592. But here after 2 this is 6535. Here it is 7410 and everything after that is changed. Isn't that so? This is because float would be able to represent fractional values precisely up to 7 digits starting from the first place itself. If you count this out, this is 1, 2, 3, 4, 5, 6, 7. Up to this point, it will print everything as it is mentioned over here. But after that, everything is getting changed. Double, as name suggests, would be able to print fractional values precisely up to 16 digits. Here you can see, up to this point, everything is as it is. But after this is 2, and here, this is 1. And that is the major difference. And long double up to 19 digits. Up to this point, there are 17 digits. After that, this is 18, 19. Up to this point, everything is printed correctly. But after that, everything is changed. As you can see over here, there is 4, 5, 6, and here it is 3, 5, 9. Of course, the precision depends on the size of these data types. Therefore, if you want less precision, then you can use float, or if you want more accurate fractional numbers, then you can use double or long double. Many scientific applications are sensitive to precision. Therefore, they will use double or long double. Some applications require precision up to 2, 3, or 4 decimal places. Then using float would be a better choice. That will save you a lot of space. Now one more thing that I would like to talk about. Again, I will run the code first and then go step by step. Here I have divided 4 with 9. As you know this thing, that when 4 is divided by 9, you get 0.44 as the answer. Isn't that so? We know the result of this expression is stored inside this variable. Therefore, when we try to print it, we would get our result. But here in this case, 4 divided by 9 gives me the result as 0. This is because here we are performing division between two integers and storing the result in an integer variable. And if we try to print this value, it will truncate the rest of the part after the decimal point, because integers won't be able to represent the fractional numbers, and whatever is there after the decimal point is simply truncated. Due to this reason, we won't be able to represent 0.44, as 44 is simply truncated after the decimal point. Now suppose I store the result into this float variable and try to print it. Maybe this time I'll get the right answer, but here as you can see, I will again get a wrong answer. It is 0.00 instead of 0.44. The reason behind that is, here we are performing the division between two integer values. Therefore, again, the result is getting truncated. Whatever is there after the decimal point is getting truncated. Due to this reason, if we try to print this value, it will only print this thing. 44 is totally lost. Because of this point 2, we would be able to print up to 2 decimal points, but because there is nothing there inside that, therefore it will just print 0, 0. Now the only change that we need to make in order to get the correct answer is changing these integer values to fractional values. That is, by making them 4.0 and 9.0. Placing 0.0 after 4 and 9 make these integer values double values. By default, they are double constants. And if you want to make them float, then you just have to place f at the suffix. If you try to print this value, then it will get your desired result, which is 0.44. Okay friends, this is it for now. See you in the next lecture. Bye-bye.